Now let's find the coordinates of a point. If A, B, and C are these points, respectively, use vectors to find the coordinates of point D if ABCD is a parallelogram. Now, if it's a parallelogram, that makes things a bit easier, right? So, let's just assume that the coordinates of D are X and Y, right? So, this is the parallelogram. This is point A, this is point B, this is point C, and this is point D. Now, since it's a parallelogram, that means that this side and this side are parallel, this side and this side are parallel. So, you can see that the vector AB is equal to the vector DC, right? Because they're parallel. So what you can do now is just equate both of them. Now, to find the vector AB in equation form, AB is equal to OB minus OA, right? And as you know that the equation of OB is basically this: 4i plus 0j minus OA. OA is this. So minus 2i minus 4j. Once you equate that, you get 4 minus 2i and plus 0 plus 4j, which is equal to 2i plus 4j, right? Now, that's AB. So 2i and plus 4j. Now we need to find DC. We know that DC is equal to OC minus OD. Now we already know what OC is. It's this, 1 and 6. So I plus 6j. We took the arbitrary values of x and y to denote D. So OD is basically equal to xi plus yj, right? So this basically equates to 1 minus xi plus 6 minus yj. And once you equate that, you get this. 2 is equal to 1 minus x, right? Because look at this. The value for I on the left hand side is 2, and the value of I on the right hand side is 1 minus x. So 2 is equal to 1 minus x, and similarly 4 is equal to 6 minus y. Because you treat the values of I and j completely separately, because one is on the x-axis, the I, and one is on the y-axis, the j values, right? So once you equate them, this is what you get. Now you can solve them. So x is equal to 1 minus 2, which is equal to minus 1, and y is equal to 6 minus 4, which is 2. So the coordinates of C are minus 1 and 2. Sorry, the coordinates of D. We need to find the coordinates D, so they are minus 1, 2.